So this is a Jeep Wrangler equipped with the 4.0 inline 6. It is a distributorless ignition. It has a coil pack right here. The older models of this, the older years of this same model are going to be equipped with a distributor. It would go where that camshaft position sensor is, right there. But this one is the newer, so it is coil pack. It is sequential fuel injection. As you can see, there's an injector for each cylinder. So here they are, all 6 of them. Here's your fuel rail, and this is where your test port is. Right here is your thermostat. That's where your engine coolant temp sensor will be. And then we get over to the manifold right here, and it's a bigger jumble of wires. So here is your manifold absolute pressure sensor. This one right here is your intake air temperature sensor. The one back here, you can see that, is the throttle position sensor. Right here is going to be your idle air controller. We'll insert a picture, but down under the intake manifold is the exhaust manifold. It's a cross flow head. So your oxygen sensors are going to be located on each bank. So bank 1, bank 2. And then there's another set farther down, but we're going to insert a picture there. Your PCM, if you can see the battery right over there, that is going to be your PCM right above it. And then under the battery is a battery temp sensor. And then we can see in the powertrain distribution center fuse box, we have a fuel pump relay right there, so you can see it there. And it's this one right here. Okay. And then the data link connector is going to be in the spot where most of them all are, inside the vehicle. And pretty much right, get in there, right there. Bam.
Okay, so we couldn't cover this in the video because this fuel tank, to access the hanger assembly and everything, you have to drop the fuel tank. But I wanted to cover number 5 right here. That's the fuel pump module assembly, so the fuel pump is inside of the fuel tank. So to replace that, you'd have to drop the fuel tank, pull that out, and then you could replace it. And it's actually the same story for the fuel filter and the pressure regulator. That's all inside of the fuel tank. So it's not easily accessible or easily serviceable, so that's why I showed up the diagram of it. Okay, now onto the ECU connectors, the pins and which circuit they're for. It'll take me too long to actually read through all these and what they're for, so I'll just kind of throw it up here. I'll zoom in a little bit on it, and I'll scroll through it just so you guys can see it and what they're all for. You can see that some aren't actually used, other ones in the parentheses. Like this one's for the inline 6 only, this one's only for the 2.4 liter inline 4. So there's different pins that aren't actually on, like the inline 6 model. So this pin probably wouldn't, it either wouldn't be there or it just wouldn't be used. And that's a very common trend through a lot of these. So that's the connector 1. That's one connector out of 3. And then onto the second one, we got very similar. That's the same one, I believe. Oh, hold on. Let me restart here. Should be. Here's connector 2. Connector 2, there's not many used here. 2 of them are for the 4-cylinder only. This one's for the 6. These 2 are for the 6-cylinder only. So that's connector 2. And then onto connector 3, we got. There's a lot more here, but also a lot of different options that may or may not be installed. So like that's only for the AC option, that's only for cruise control, inline 6, cruise control, automatic transmission, AC option, and then there's just some pinholes that aren't used. So that is that.
So we're starting from this top left up here. This one's number 1, but that one's empty. So we're gonna move on to the second one, which is reading a little funky. It's fluctuating between 0.3 volts and up to around 1 volt. So moving on to the next one, that one's empty. So on to pin 4, that one's 0, so that one could be a ground. Same thing with pin 5. On to pin 6, we have around 4 volts, 4.2 volts. Could be signal reference. Pin 7 is going to be pretty low voltage, could be another ground, could be something different. Pin 8 is empty. pin 9 is low voltage as well, 0.015. 10 is empty, 11 is empty, 12 is empty, 13 is empty, 14 is 5 volts again, so that could be another network system. And 11 is empty. I forget which pin I was on.
That's 15 you're on right now.
Oh, okay. So 15 is empty. And then 16, that one is 12 volts, so that is battery positive. Okay, so we're in a Pontiac Grand Prix right here, and we plugged in the scan tool, and there is a whole list of ECM codes or MIL codes, malfunction indicator light codes, DTCs, and we are going to unplug one of the sensors and see if the vehicle starts. Here we are starting the vehicle, looking at the PIDs, the live data. The vehicle just started. So if we scroll through here, there should be so you'll go into live data there. You can see all the different relays, fan control relay, AC relays, switches. See all you can see the engine speed, see how it's running at 1000 RPM. There's the ignition signals. Startup ECT, it's 20 degrees Celsius. AC pressure sensors, IAT sensor, and then the actual ECT sensor right here, which is at 28C. So we will go ahead and do that, and we'll let it run for a little bit, see if it changes as the vehicle warms up. Okay, here we are, about 5-10 minutes after running it a little bit. Engine's starting to warm up. You could see that the degrees has gone up around like 40 degrees Celsius. IAT has stayed around the same, which is to be expected. And then if you see the AC request signal right there, if I press the AC button, you could see that change from yes. And then you could also see the RPMs fluctuate as the compressor engages. Okay, so my partner here is going to unplug the engine coolant temperature sensor, and we are going to see, hopefully see that value either drop off or change. Yeah, you can see it just went to -39 right there. He's gonna go ahead and plug it back in. We're gonna see it change, and maybe we'll see the RPMs change. Okay, so the RPMs didn't change that much, but the value did go back up to 91 degrees Celsius.
While testing, we determined that this is actually a pull-up resistor. So when we tested the ground, we got just like 0 volts, and we were really confused by it, and we thought we did something wrong. So we checked the positive, and it's only 1.7. This is a 5-volt reference. So the fact that we're getting less than 5 volts to the sensor means that it's a pull-up resistor, because there's a higher resistance located somewhere, probably in the PCM, that is limiting the amount of voltage the sensor can get.